Let's get started. The projectile motion, that's what I really want to go over. Then I don't want to spend a lot of time going over it. It's fairly basic. We'll do a few practice problems, get you ready for a quiz, and then our next class on the, when's our next class? 26th, is that correct?
Yes.
26th on Wednesday, we will have a quiz, okay? All right, yeah. Okay, now. So, we've gone over this already. So let me give you a problem directly. All right? Let's do three problems at once. Okay? Hopefully I can get them all on the board. Okay. And then all right. Are those all on the board? We have V naught.
Yeah.
Yes.
You know what, they're all on?
Yeah.
Okay, let me go like this. All right. Oh, by the way, I may be observed, you may be observed on Wednesday, okay? So what we'll do is, I want to do a lab on projectile motion, a little bit of a lab, hopefully we'll get one set up. Anyway, it's actually, GEMS is going to be, GEMS, somebody or other, they're going to come here and they're observing classes to see how we're doing. So, be on your best behavior with all of your classes. Not that you're not usually on your best behavior. Well, most of you anyway, right? So, make sure you are on your best behavior. All right? Now, let's do this. Let's look at three separate problems. All right. We'll say we have three things. We say we have V naught, we have, well, that was terrible. We have dy, and we have dx. Can you see all that? Does that come out? Yes? Yes? Okay. So let me put those in for each. Fairly basic stuff. This is dy, and then this is going to be, v naught, V naught, and then this is going to be dy, and then dx, and then dx. Okay, are we all right with that? Yes? And then what we'll do is we'll put in some values. Okay? And we're going to look for different things. Okay? Okay? All right. This one, we'll say, is going to be 200 meters per second. This one is going to be 500 meters. And then this is going to be what we're looking for. Okay? Yes? And then this one is going to be 1,200 meters per second. This one is going to be very tall. And this one is going to be, let's see. We have that one, all right, so let's do this. This is going to be 10,000 meters. Okay? It's 10,000 meters. Okay. What else do we need? Okay, so we'll say this one is 1,000. We'll say this one is, we'll say 16,000 meters. And we want to know how fast that is. Okay? What else? Is that it? Okay, so we have blue, we can draw in the trajectory. We can draw in the trajectory. Okay. All right. So, what I want you to do is, we'll talk about them. Remember we did this on, what day, when did we do this? We did it on like Thursday, right? Didn't we? Yeah. So, let's look at some of the math involved in this, shall we?
Yes.
Okay. What kind of math do we need? Well, we know that we have Vx or V naught. We'll say Vx, it could be naught, okay, because it's initial, right? I'm just simply saying that it's going to be the horizontal velocity is going to be dx over tx, and then this one will be then we need what? What's another equation? You're going to have to rearrange this possibly, right? Yes?
Yes.
What other equations could you write from this? Anybody? You could write what? dx equals what?
Tx times Vx.
Right, very good. Tx, Vx, Tx, right? And what else could you write? Tx equals what?
Dx over Vx.
Tx over Vx, right? Right?
Yes.
And then what else could you write?
That's it.
Well, yeah, though for that particular equation, that's correct, Mohammed. But what else could you write in terms of what else do you need? You could write, we have a vertical, right? And I'm going to tell you this. If you haven't taken physics, you really don't know. And I'm just going to give you I don't really want to teach gravity in terms of this kind of problem. We learn gravity in terms of universal gravity and the attraction between two masses, but we know that, and many of you have had this in math, by the way, okay, as an equation. You've had let's see, you've had d equals total distance equals, right? Equals distance initial, correct? Plus V naught T, correct? Right? Yes? Plus 1/2, what? 1/2 GT squared, right? Is that right? Yes? Does that look familiar to you?
Yes.
Okay. This is total distance. But this is going to be 0 because we're starting at 0. We're starting at 0 as the top of the cliff. So when it falls, it's going to fall from 0. We're saying it's 0. Clear? Yes? Okay. So then this results in V naught T plus 1/2 GT squared. Now I know that some physics teachers and some physics students may say, well, I know, but is acceleration, isn't it negative going down and positive going up and blah, 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 blah. We're just going to say when something accelerates, it's positive. All right? Is that okay with you?
Yeah.
Are you all right with that? You have no problem with that? Okay. Intuitively, it makes sense, and that's just the way we're going to do it. Okay. But what is going to be the initial velocity that it falls vertically is going to be what? What's the initial vertical velocity going to be? I'm shooting this horizontally, so the vertical velocity at times 0 is what? 0. So doesn't that equal 0?
Yeah.
Correct? So what are you reduced to? You're reduced to 1/2 gt squared, right? Equals d, correct? What is g? Isn't that a constant? Isn't it?
Yeah.
What's 1/2, and what did we say? We say g equals 10, right? Is that correct?
Yes.
Right? Okay, so if that's true, therefore, what? The distance is going to equal 5t squared. Right? It's a cool equation. Is that a good equation? Can I erase all the other stuff? You have it on film, so that's going to be, I'm going to erase this. Is it a little stuffy in here? We'll have it.
So isn't V naught 200?
I beg your pardon?
V naught, isn't it 200?
The question was, isn't V naught 200? Yes. However, that's in the x direction, correct? As soon as you shoot that, it's going to start falling, right? But the velocity in the y direction is going to be 0. That's the initial y direction velocity, right? The idea is that when I shoot this, that the projectile and the penny or the stone or whatever will hit the ground at the same time. Correct? Do you remember I drew these vectors in? So we'll shorten this just so it makes a little more sense. So this is that one, and then, right? And then the next one is going to be a little bigger, right? But this one's going to be the same, right? We'll go down here a little ways, and it's going to be bigger. But this one's going to be exactly